Hello everyone. In this video, we're going to be covering the topic of normal distribution. Okay. So before we dissect the words normal and distribution and understand what these two different words mean, let us take an example of a die. Right? Die has six faces, and those six faces contain numbers. Numbers ranging from 1 to 6. Okay, so if you roll a die, and if I take the event x, and x is the number that is shown on the top face of the die. So if I take this die and I see that what exactly is the number that comes out on the top of the die, so there are only six possibilities that the number would be a set or a subset of this particular x event, right? The number would be 1, 2, 3, 4, 5, or 6, nothing else. So if we try to create a graph where on the x-axis we have the event with us, and on the y-axis we have the probability of the said event. Okay, so let's see what it will look like. So on the x-axis we would have 1, 2, 3, 4, 5, and 6, right? And on the y-axis, if I take any random number, let's say 3, so what is the probability of getting 3 when I roll a die? So the probability of getting a 3 would be favorable outcomes, that is 1, and total number of outcomes, that is 6, right? So similarly, the probability of getting 1 or 2 or 4, 5, or 6 would also be 1 by 6. So the probability of getting any number from this particular set is 1 by 6. So on the y-axis, I plot 1 by 6. So this would be a straight line, right? This would be a straight line. This is the case where x is a discrete variable. Discrete is belonging to a particular discrete class. However, what if x is a continuous variable? Continuous is any number from 0 to 100, right? So if I take in the marks of students in a particular test out of 100, now this would be a continuous variable, because the value can range from 0 to 100 and will not belong to a particular class. So if I try to draw this probability distribution graph, where I have on the x-axis the marks of the students and on the y-axis the probability distribution of the students, so if I am to think that I'll get the same graph as the previous graph, this would be very wrong, right? Because in a continuous variable, it is almost impossible in real life to get a graph like this, right? So then the question arises, what kind of graph actually is obtainable when we have a continuous variable? So the answer to that is, in most of the scenarios, when we have a continuous variable, and if we create a probability distribution curve of that continuous variable, it would look something like this, right? In mathematics, we term this as a bell-shaped curve. Okay, so this particular distribution, in which we get a bell-shaped curve when we draw the probability distribution graph, this is known as a normal distribution. So any data set that follows this kind of distribution is said to be normally distributed. Okay, I hope this is clear. Now there are some facts that are important to know whilst dealing with normal distributions. So if a data set is said to be normally distributed, we have established that it will have a bell-shaped graph. Okay, this is your x and this is your probability of x. Now it is said that the graph is symmetrical about the center. Okay, this is what I'm telling you here are facts. Okay, these are not assumptions or hypotheses. So assuming that this particular data set has a mean of mu and a standard deviation of sigma. Okay, so the graph is symmetrical about the center, and the central point of the graph would be the mean of the data set. Okay, I am again repeating that this is factual and you need to memorize it. Okay, the center of the graph around which the graph is symmetrical is the mean, is also the median, and is also the mode. Okay, these are facts about normal distribution. Now another thing that comes into play is the standard deviation. Now I think you would recall from the last video that I told you that standard deviation has got something to do with the spread of the graph, right? So spread is how far spread is this graph. So now we know that spread is related to standard deviation, but we don't know how. Don't worry, I'll explain it to you. So the answer to that being, it is said that 65% of the area of the graph lies between one standard deviation. Okay, so this particular point is mu plus sigma, that is mean plus standard deviation, and on the left hand side of the mean would be mu minus sigma. Okay, so this particular area is constitutes for 68% of the total area of the graph. Now similarly, it is said that 95% of the total area lies between two standard deviation. That means mu minus 2 sigma and mu plus 2 sigma. Okay, and 99.7% of the total graph's area lies between three standard deviations, that is mu minus 3 sigma on the x-axis and mu plus 3 sigma on the x-axis, right? So this is factual. You do not need the proof for it right now. You just need to remember this is something that might arise in a question. What kind of question are we talking about? Don't worry, I'll just take a question. So assuming that you take the heights of students in meters, right? And I tell you that 68% of the total students lie between 1.1 meters and 1.7 meters. And then I tell you to find the standard deviation and find the mean of this particular data. So if I know 68% is a figure I have encountered before. So I know that 68% of the total values of the graph will lie between 1 sigma. That means mu plus sigma and mu minus sigma. So I can attribute 1.1 meter to mu minus sigma and 1.7 meter to mu plus sigma. If I add these two equations, so it becomes 1.1 plus 1.7 is equal to mu plus sigma and sum of mu minus sigma. Okay, so this would become 2.8 is equal to 2 mu and mu is 1.4 meter. Okay, I hope that similarly you can calculate the standard deviation as well. So now you know a little bit about normal distribution. This will help you to further understand what is data skewness, which we will discuss in the next video. Thanks for watching. I'll see you guys in the next video.